So let's start talking here, building out the servers and the storage and the network switch of what we call our legacy environments, right? We've been using these environments for many years now, and as the computers move from mainframes to personal computers and servers and the x86 platform, this is what we call kind of our legacy, our existing environment. And then here in the last couple of years, we've had the introduction of cloud technologies and something called Converged, which we're going to talk about here in just a moment. And then as time continued on, we started entering into this more software-defined environment. And the new term of the day, of course, hyper-converged, an extension of the converged environment. And then the future holds for us this combination of all compute, memory, and a different way to communicate called photonics. So these are kind of the four primary areas that technology is moving towards. And let's go ahead and just review each one of these individually. So from the 1990s or so, 1980s, we started building up what we call siloed IT architecture. And no harm, it's just the way it is, right? We build out the server, storage, network, security based on the business requirement. For example, an email solution may be inside one of these silos, or a database, or a file share, things of that nature. Things that did not really go in silos as time progressed was security, for example, or your network router infrastructure. So, but generally speaking, siloed. And then here a couple years ago, within the last 5 years or so, we really started seeing the onslaught of converged systems, where we're taking all of the hardware and mixing it with software to provide automation. And so through software, policy, and process, we can then manage these servers, network, and storage devices and have them delivered to us as a converged system. So for example, HP sells a converged solution that has everything pre-wired, all the software running and working within all of the solution to give you an optimal solution. And then of course cloud in its many definitions, whether it be private cloud or dedicated, right, or public cloud, which often refers to as a multi-tenant, although multi-tenant can also exist within the private environment. And then of course hybrid clouds, which is a mix between the public and the private cloud. All of these clouds providing as a service for us, right? So we went through many years here of everything as a service, storage as a service, compute as a service, etc. Email as a service, backup as a service. So yes, granted, we want to make it consistent and repeatable. And I think the takeaway here, as we moved from the silos in 1990 into the converged architecture with cloud, we now are moving into something that is a little more automated, repeatable, and scalable. Then of course we move into the third category here, which is software-defined networks. Software-defined networks. And this is not, I shouldn't just say networks, but software-defined everything. So just like it was X as a service, it is now software-defined storage, software-defined infrastructure, software-defined data center, etc., etc., etc. And so we're using this term, everything starts with software-defined now. And this is a good thing. We're adding more, we're building, of course, on more automation, more ways to reduce operating costs and increase efficiencies, repeatability, and consistency within our environment. So this is good, right? Software-defined X, whatever X may be. And of course, I put hyper in there to talk about hyper-converged. So now we're not only converging the large components as seen on the far left there with the servers, network, and storage, but we're compressing and hyper-converging everything within our environment to add software, process, and policy around that. And then, of course, we have the future, which is the collapse of all compute-related functions onto a single chip, right? We're running out of space. And so we need to be able to have these things more consolidated. And frankly, a great example of that is your cell phone, or maybe you're wearing some wearable technology like a watch. These are great examples of compute and graphics all being put down onto a single chip, as well as other functions that are carried within a compute environment. So we're starting to see this collapse of this joining of compute, right, standard just CPU cycles with your graphics, right, and they're starting to merge, and we're going to see that continued in the future, as well as the bottom, which really refers to what we call memristor, which is the combination of all storage type of devices. So your hard drive, your RAM, your DRAM, all of that, all of it's going to be combined in the future and then connected by photonics, which is a very high speed interconnect. So these things are technologies of the future, not today, 2020 and beyond, but something to keep aware of as we look at the progression of information technology environments.